Welcome, everyone. Welcome to today's FabFems Friday with a focus on petroleum engineering and geosystems and hydrogeology engineering. We're excited to have you join in today. We have a fabulous panel that you're going to get to hear from. We will start with a number of pre-selected questions for our panelists, but we'll also be taking questions from you, our participants. So please use that Q&A box to the left to ask your questions. Submit them in the little box at the bottom, and you can do that at any time. And we will come to those at the end of our facilitated questions and try to get through as many as we possibly can. My name is Trisha Berry. I'm director of the Women in Engineering program, your host for today's FabFems Friday. And again, today our focus is all on petroleum engineering, geosystems, and hydrogeology engineering. And I want to get right to it with our fabulous panelists. So let me switch to this view so we can see everybody. And we're going to work our way through all of them and hear who all we have on this fabulous panel. We're going to hear from them about who they are, where they're from, their degree, where they're at today, what their job is, what they're doing, and maybe throw in there a hobby or some sort of out-of-school activity, because we all need that little break from our day-to-day. So share something in that space as well.
Okay.
So,
I apologize, I'm probably going to have a lag. I'm Karen Hagedorn, and I'm currently sitting in Luanda, Angola, so in Southern Africa. But I'm originally from Houston, so this is far away from me. I am the development manager for SO Exploration Angola, which is a subsidiary of ExxonMobil. And what does development manager mean? That means I kind of have the long-term view for developing our assets. So I've got subsea facilities, reservoir, geoscience, digital transformation, and commercial all under me. So lots of different technologies that I oversee. I have a petroleum engineering degree from UT, 1986. Yes, that makes me old. And then I also have a PhD from Stanford, so I went to 2 different schools. But what I like to do, I love to read. I'm doing a lot of that right now. It's a very good time to do a lot of reading. And I love to travel, which I'm not doing very much of right now.
My bad, I needed to unmute myself. My name is Heidi Higginson. I'm an incoming 5th year petroleum engineering undergrad at UT. I previously worked for Anadarko, whenever it was Anadarko, Chevron, and Marathon Oil, as well as Enverus. So those were my internships. And let's see, hobby or out of school activity. I have a dog named Milo. I like to hang out with him a lot. I also like to hang out with my friends, and whenever there's not a pandemic, I like to go and check out different restaurants around Austin.
Me? Okay. I was waiting for a nod that I'm next. My name is Masha Pradanovic. I'm originally from Croatia. I am now associate professor at Petroleum and Geosystems Engineering at UT Austin. I came to petroleum engineering via applied math degree. It's actually all of my degrees, both. And I have a wonderful coworker that you can see. Okay, can you go to that for a moment? So, just a moment. So, I have very active children. This one is a 5-year-old and the other one is 3. And one of the best things that we've done in terms of outdoor things and hobbies is to check out a different state park in Texas every Sunday. Stop it. Okay.
Hi guys, I'm Carrie Colbert. I graduated from UT with an undergrad in petroleum engineering in 1999, so last millennium. And I worked in the oil and gas industry for almost 20 years, 18, but I'll just round up. I was at Anadarko for 5 years and then at Hillcorp for the majority of my career. And along the way, got my MBA from UT while I was working. And now I do two things. I do like online content creation, totally not related to engineering, but I also run a venture capital fund, and we invest in female founders in all sorts of industries. Basically, women, companies started by women who develop products or services for women. So that's where I am today. Totally not in engineering, but still so grateful for that education and background. Oh, and I have a 3-year-old. Yeah, so that doesn't leave a lot of time for hobbies. So kind of 2 different businesses and a 3-year-old and, you know, quarantine life. So that's about it right now.
Hello everyone, my name is Zoya Haydari. I am an associate professor at the Hildebrand Department of Petroleum and Geosystems Engineering at UT Austin. I do petrophysics and formation evaluation for research at our department, and I have been enjoying that so much. Other than when I'm not doing petrophysics, or when I'm not in my office doing work related to stuff, sometimes I paint. I do painting, and this is a hobby that I have outside.
Awesome. Well, thank you. So as you can see, participants, we have a fabulous group of panelists to answer your questions with a wide variety of experiences. And we're going to dive into our first question, and they're all going to have a chance to answer this one. And we'll just go in the same order again. So can you each share a little bit more about why you chose the field that you chose? Why did you choose petroleum engineering for your major or career path? And maybe dive a little bit more into the work that you do and give maybe an example of a project or something that you've worked on.
Trouble with the mute button. Okay. So why did I go into petroleum engineering? Well, I mean, it's kind of a cliche, but I have to say my dad was a petroleum engineer. And so he would bring home, you know, oil samples and rock samples, and he would go to these absolutely fabulous places and come back with all kinds of pictures. And so, you know, that kind of got me introduced to at least the concepts. But, you know, my favorite subjects in school were chemistry and geology. Which is a good combination for a petroleum engineer, obviously. Always knew I wanted to be an engineer. That was just math and science was my favorite thing, and so that was how I chose the specific branch of engineering was based on my 2 favorite subjects. What do I do? Let's see, probably the most interesting thing I've been working on lately is we just did a big new project that we're about to kick off that had commercial. It has some drilling involved, it has some project activity involved, it has a lot of subsea work involved, and so it's really kind of my entire organization getting ready to kick off a major redevelopment in a fairly mature asset. So it's pretty exciting and gets to bring together all of the things I like to do.
Okay, so my reason for getting into petroleum engineering is pretty similar to Karen's. My dad was in the oil and gas industry as well, and my number one reason for getting into oil and gas, like whenever I was in high school at least, was the travel opportunities. My dad went to Africa, Singapore, Indonesia, lots of really cool places, and I really value that as an individual. So having that opportunity to explore the world and see different cultures really drew me to petroleum engineering. And then second off, whenever I was in high school, there was kind of like the leftover, kind of like a panic from the BP oil spill. So I thought that for me as a petroleum engineer, I thought it would be a good opportunity for me to have like a little bit of input so that potentially bad things don't happen anymore. And then let's see. So the third reason I got into petroleum was also like the job stability. Even though the petroleum or the oil and gas industry is a cyclical industry, there's a certain amount of job security with like being a long-term employee for companies, and I find that an appealing trait for oil and gas. I forgot the things about my internships. So I did several, I did several internships, starting with Anadarko in high school. I did a lot of like data QCing, like quality control from my high school internship. And whenever I was a freshman, I worked for Chevron over the summer in Midland, Texas. And I was doing a production internship where we were focused on the central drinker unit, which is a water flood. That was really cool to see, especially as a freshman. And then my sophomore year, I was doing drilling in Oklahoma City, Oklahoma. And that was really cool as well because I was doing my project on shaker screens, which is very like hands-on and very like visual project, which I really enjoyed. And then this past, or not this present year, but last summer, I was doing an internship in Houston, Texas for a marathon with focus on completions and frac design. So it was really cool. Got a nice coverage of oil and gas so far. Thanks.
So I think it's fair to say that petroleum engineering and I found each other later in life. So my parents were actually teachers of history and psychology, so in social sciences, and I actually favored math and physics. So that basically informed my choice of applied math, and I really enjoyed applied math. Now, what people don't know is that actually fluid mechanics is something that is heavily studied in applied mathematics, because the equations, differential equations involved, are pretty complicated, so they require mathematical treatment. And then with this being basically, I was doing my college in 90s, and then later on 2000s, that's sort of like the boom of computing and parallel computing, which is required for solving those equations. So this day, I'm sort of excited by fluid flow. There is no oil business without fluid flow, so here we have it. And I was introduced to the petroleum engineering programs or the problems in graduate school. And then after finishing PhD, I went for postdoc, which was related in petroleum engineering. And moment by moment, here I am, professor of petroleum engineering. So what I actually do, I have a little prop here, which is a little glass jar, my favorite thing, that is full of beads that you don't see because they're transparent. They're water beads or ore beads, they're called these days. So when you fill it up with water, they become transparent because they're full of water themselves. And also there's red, which is oil. So as sort of like, this is sort of a reservoir model. This is your migration of oil going up to the cap rock. So you can see these trapped blobs of oil, which is in red. What I do for a living is I simulate that on a computer. So essentially, that is one of my, so if you grab some Orbeez and water and essentially baby oil and food coloring, you can, in your favorite jar, this is from my favorite jelly, you can make yourself a model reservoir.
Such a treat to hear about everyone's experience. I think you're already getting a feel for what all you can do with an engineering, specifically petroleum engineering education. You can really, kind of craft a life and a career that you really love and enjoy. So from my background, I, as I said, worked in the oil and gas industry for about 18 years and had the chance, I was 5 years at Anadarko out of school, both in reservoir and petroleum production engineering. And then at Hillcorp, I ran our reservoir engineering as well as our reserves. And then after I got my MBA, moved over to the finance and investor relations side and ran that. What I really took away from Hillcorp was the entrepreneurial spirit and learned so many valuable lessons. So that's what I credit with kind of igniting that passion in me. And so, I was able to see and do so many things during my time there that when I was about 38, I just decided to retire from that. I didn't know exactly what I wanted to do next, but I knew I was ready for a new challenge, a new chapter, if you will. And I'm forever grateful for both the technical and business lessons that I learned there. And with that, I was able to go forward, and now I'm able to help other business women. You know, those lessons that you learn in the oil and gas industry, in engineering, carry over into so much more than just that, you know, if you want. So I've been able to take those experiences forward and do my own thing now.
Okay, so I am a rock scientist, as I mentioned. So my interest in rocks kind of started when I was very, very young, when I was a little kid, a little girl, and when I was hiking with my parents. So my father used to pick a piece of rock, and he was talking about that for hours. And I was always wondering how he can talk about a piece of rock like that. My father is a geologist and my mother is a mathematician. And I guess the combination becomes a petroleum engineer, but it was not that simple. So I decided to become a mechanical engineer when I went to college. And I was working on different types of projects related to mechanical engineering. And at some point, I ended up doing some sort of signal analysis for understanding what's going on in human body, the things that we cannot see on the surface. And this is exactly what I'm doing as a petroleum engineer these days. I do formation evaluation. And indeed, what formation evaluation is to figure out how the subsurface looks like without seeing the subsurface directly. So what we do is to send some sensors to the borehole, or we make some measurements from the surface. And from the readings of these sensors, we figure out what we have at different depths. What is the quality of the rock, what the porosity is, how much hydrocarbon we have, and whether we can produce that and how we can produce it the best way. So something that we cannot see, and we get some measurements, and it is like solving a puzzle. And that is actually the interesting thing about what I'm doing these days. And that's one of the reasons that I like the type of research and the type of job I have, because it never gets repetitive. And there's always a new puzzle to solve. And that is.
Awesome. Thank you each for sharing a little bit more about the work that you do and how you got to where you are. So within the Hildebrand Department of Petroleum and Geosystems Engineering, we have two majors that undergraduates can pursue. And there's often questions, what's the difference between those two? Why one versus the other? What's the difference? What can you do with these two different undergraduate degrees? So I'm going to throw these to our two faculty members. Can you, one or both of you, explain a little bit more about the differences or what people might, how they might decide or choose and what those choices might take them?
Well, so in the petroleum engineering department, I can talk a little bit about petroleum, and as you mentioned, Masha, you can talk about it. So in the petroleum engineering department, I hear an echo.
Oh, I think Masha.
Okay. The petroleum, we have actually certain petroleum courses that the students would take, and they gain information and knowledge about reservoir engineering, about drilling engineering, about formation evaluation, and about production. And we also have some courses that can give the students the knowledge of computational work, they get exposed to some experimental type of work that can help them to characterize the reservoirs in the future. So that's actually a wider scope of different type of areas that we try to educate the students and help them to grow inside those disciplines to see actually what their interest is, and to make them ready to join the industry if this is what they are looking for, and also actually making them ready actually to start the next chapter of their education, which will be the graduate school if this is something
There's
they pursue
basically
later on.
limited time that you have in
Masha, is
4
there
years
anything else
to
you want to add
study,
about
and
petroleum
petroleum
program?
engineering or any kind of
Particular-
subsurface engineering does take a lot, really, because you need to know a little bit of everything, all of the engineering, really, and then geology to basically analyze. So some of the courses in petroleum engineering, like drilling, are essentially swapped for more like groundwater hydrology or structural geology that helps be more of a steward of the resources on the ground and help protect them. So typically our geosystems engineering students go into stewardships of the resources. So every company, a petroleum engineering company, will also have sort of like a department or part that is also helping remediation or anything that might help remove during spills. There's a need to guard for spills, and there's also a need to guard any kind of area. So as we drill, we are typically drilling really deep, and the aquifers are way above that, but there is one needs to ensure with the completion that you are not basically interacting with any water resources, and geosystems engineering will often do that type of work.
Awesome. Thank you. Thanks for clarifying a little bit. So our next question is one that's come up many times in our FabFems Fridays webinars, as many of our students that are participating are trying to figure out, is engineering for me? Where do I want to go? And, we all sometimes have these doubts or feel like maybe, we're experiencing that imposter syndrome of maybe we don't belong here. And so I want to throw out to both Karen and to Carrie, have you experienced imposter syndrome before? Have you ever had doubts? And if so, have you had to, overcome those? What's helped push you through, and how do you resolve that?
Okay, the answer is yes. I certainly have. Probably the first time I really felt the imposter syndrome was when I went to Stanford for graduate school. Wow, what an incredible bunch of colleagues that I worked with, and they were all outstanding at math. And I'll be honest, I'm not that great at math. It's not my strong suit. I can do it, but I didn't compare to them. And so that, that was very intimidating for me, was just to realize, wow, I'm in the same degree program with these guys, and I can't compete with them in a certain subject. What I did find was I had strengths that they did not. And I think that's what I rely on whenever I do get into particularly a new role where I'm outside of my comfort zone, is to remember what are my strengths and what do my strengths bring to that role. And, because there's always a strength we all have, and frankly, there's always an area for improvement we all have. The other thing is to really make sure when I start a new role or when I'm doing something that's out of my comfort zone, know who you can rely on, because no one knows everything, but there's always somebody who does know. And really understanding the network and who you can leverage to make sure that you can deliver the job that you need to deliver, recognizing you use your strengths, you use their strengths, and together, you're really not an imposter, you're a team. And that is probably where the most success I've seen. So, you don't have to be a math expert, you don't have to be a science expert, you don't have to be a PhD, but you can be. But if you leverage the skill sets of the people you know, and you develop the strong relationships that let you do that, I think that's how you succeed even when you're outside your comfort zone.
That's really great advice from Karen. I'll say that, to the first question Tricia posed about belonging, I think you could see from this panel that there is not, a typical petroleum engineer or engineer. So from my perspective, I just always kept in mind, like, you don't have to conform into some mold that you think you're supposed to act like and look like and, be like as a petroleum engineer. You do you stay in your lane and know your strengths, as Karen said, and then really build that network around you. And really, I would say that, like, when you go into a meeting or a big presentation, know your stuff, prepare well, and the more kind of competence you can kind of prove to yourself, if you will, it'll help build your confidence, and slowly, that'll get better with time. But I'll tell you, I still have times that I'm like, now, because I've started over in a new industry somewhat, and it still comes back, like, am I really running a multi-million-dollar venture capital fund? Like, I never thought I would be here. What do I know about this? But really just impress yourself over time with, kind of your competence and your skills and your strengths, and just surround yourself with a great support system that kind of fills in the holes that you might have. And you can, push through any of those uncomfortable feelings that we all feel from time to time.
Awesome, thank you. I'm going to come to Heidi with the same question. But first, I'm going to remind everybody to make sure you're asking the questions that you have in that Q&A field. We'll be coming to those here shortly. I just have a couple more questions I'm going to pose to our panelists. So be ready and throw your questions in there. So Heidi, similar question to you. Have you had to overcome any obstacles in your engineering college path?
Let's see. So one of the challenges I had to overcome
that as a student?
Over my previous 4 years was kind of like not that early on, but like midway through, I failed one of my classes. And that set me back not only in my actual degree plan, but also like mentally and in my confidence. So for my degree plan, it was like a prerequisite for one of my other classes. So it kind of pushed me back in my actual degree and my actual course of college, which contributed even more to me feeling less confident and like, oh, can I actually do this? Like, is engineering something that I should have gone with to begin with? Like, should I have just not even done this? So that was a big confidence shot. But my family, my friends, and some of the faculty actually were really great at being support systems and being really encouraging. Just talking with people, hearing their own experiences. Some people had similar experiences where I was having an interview with somebody and they were telling me, like I said, oh, hey, I have to retake this class. And they were telling me, oh, hey, I failed that class too. And it was kind of funny because like they're a full-time employee for this company that I'm trying to get a job at. So it was really cool to have that similar experience. And then, yeah, so like people who are full-time and then other students. They're on my previous internship, I'd say about half the girls there were also 5 years. Like they were taking 5 years. And I was like, oh, wow, like it's not that weird. It's not like something that you should be like ashamed of or like sad about, because a lot of people take extra time in their college program and a lot of similar things happen to people in college that isn't like unique to you and you shouldn't feel bad about. So I think having the support of my friends, family, and then just like peers and faculty have been really amazing in helping me overcome like just failure pretty much and that mindset. So yeah.
Awesome. So I'm going to reiterate a couple of things that were said there, because I think it's really important to hear, is that you don't have to be perfect. You don't have to be perfect at math. You don't have to love every single subject that you're going to probably have to take as an engineer or scientist down the road. But you find your way and you navigate and you find that support system to help you get through. And then you find those amazing opportunities down the road. And failure is part of the process. We've been celebrating that in our summer camp experiences for the students that are in our summer camps and doing our engineering challenges. And we figure out how to push our way through those failures and figure it out and move on and do great things. So I wanted to make sure that we reiterated that to all of you, because those are really important life lessons. And definitely when you're in college, you'll feel all of that, and that's normal. And having that network to be able to talk with, and your friends and your faculty and the role models in industry ahead of you all can help you understand that feeling's normal. And will happen frequently to not just you, but the guys around you and everyone else around you as well. Okay, so my next question is for any of our panelists that would like to answer. We have questions about, how is petroleum engineering different from other majors? We heard a little bit about the difference between the geosystems side of the petroleum engineering world and the petroleum engineering side, but how does all this differ from chemical engineering or mechanical engineering if students are trying to still decide between the different majors? Any of y'all can go. Go ahead, Masha.
Petroleum engineering really encompasses all other engineering and geology. So it takes a little bit from everything. And in that sense, you can find yourself somewhere, for sure. One thing and that's due to geology, one thing that is sometimes hard for people to take is the uncertainty. We collect a lot of data. We have the big data problem. Every industry right now has a big data problem. That means that a lot of data is collected and it's constantly streaming, and we're struggling to analyze it in real time so that we can make a decision. At the same time, our data is still sparse. It's here and there. So if you're not okay with that uncertainty, it's both an opportunity and challenge and a puzzle, is what I call it. Like there's constantly puzzles, but you're not in control. You're not building a device that you can completely analyze, dissect, take each part and then test it separately. That's essentially not possible. So everything is always kind of interacting, and you are just kind of seeing this response that you're supposed to somehow analyze in reverse. So that's a challenge, but those who are in petroleum engineering love that challenge. If you want to be in full control, what's coming in, what's coming out to the third decimal, then maybe petroleum engineering is not the best degree. But that said, in terms of problems, there's all kinds of problems.
Yeah.
Anybody else want to jump in?
The subsurface is really the part that distinguishes, I think, the petroleum industry or the hydrogeology, hydrosystems. Is the first thing they taught you when you started engineering is step one, define the system. We can't do that. So that is one of the most challenging parts, but it's one of the most interesting because you're doing a lot more deducing and investigative work as opposed to necessarily being able to build and design things as the way you want them. But I think the other is all the reservoirs are different, so every field is different. There is no, analog. There is no, we've done this one before. It's always something new, which I find personally very exciting. But the other thing I think that's unique, at least about the upstream, is that it is where it is. We don't get to build a plant where we want it to be. We have to build it where the reservoir is, where the rocks are that have the oil in them. And that makes for a lot of challenges. It could be in deep water, which if you've ever looked at some of the engineering we do in thousands of feet of water, it's like watching them go to the moon in the 1960s. It's quite amazing what we're able to do in these incredible environments. It could be in the Arctic. You could have to design for earthquakes. It could just be a lot of different things, and every one of them is an engineering challenge we have to get around because the reservoirs are where they are. They've been there for a long time, so we have to try to figure out how to work with what we have as opposed to design something we want sometimes. But I find that exciting.
Awesome. Any other thoughts on this one? All right, well, I'm going to turn it over to Sammy then. We've got questions coming in, so keep questions coming in, everybody, and we'll start making our way through the questions that y'all have been submitting. Sammy is one of our engineering students who works in our Women in Engineering program office, and she's become our fabulous FabFems webinar Q&A facilitator. So, Sammy, I'm going to let you take it away.
Where do you see the future of petroleum engineering considering the recent emphasis on climate change And with this, would it be more difficult to find a job with a petroleum engineering degree? And first, I would like to hear from Karen, please, and then if we can go over to Dr. Pradanovic.
Well, as I mentioned, I graduated in 1986, and the end of the oil business was at hand at the time. Obviously, that didn't happen, and so it's been reinvented over and over and over again, and will continue to do so. So I think, you know, there will always be jobs and opportunities. They may look a little different because everything's going to evolve, but I think there will be opportunities. In terms of climate change, I mean, I think the most important, problem we have to solve is how to balance delivering the energy needs of the population with protecting the environment, protecting the climate. There's still, something like 1 billion people who don't have access to electricity. I mean, I live in Angola. I drive by them every day. And so there's still a tremendous need for energy. And there's a tremendous need for different sources of energy. And so I think it's still an exciting challenge. The industry will evolve. The way things look when you're working will look very different than the way they looked when I was working. But I think because the demand for energy is there, and because we need really good people to solve those challenges, to provide that in addition to the responsibilities we have for the planet, I think there will always be opportunity.
Thank you. Dr. Pradanovic, I think you need to unmute.
Okay. It seems that my touchpad is really sensitive, so if I'm pressing for too long, it's gonna mute again after unmuting. So, oh well. So one thing that we have to understand is that people always like to blame others. So petroleum engineers are always blamed for delivering energy that everybody else actually needs and wants. So it's really a society discussion that we need to have. Even during the pandemic, this recent past month, the total need for oil went down only 20%. 20% only, and for 2 months, basically, most of the world was shut down. Or at least all of us as individuals didn't move as much. We still don't really travel, right? So the demand for energy is there, and yes, there is still more than 1 million people without it. And if we are sitting in our air-conditioned worlds and we are connecting online that we are now, that is all needing energy, who are we to tell that other person next to us that they cannot have access to it? So that is a question, and climate change and effects it has on climate comes together with it. So this is something that we have to have as a society. This is not something on a petroleum industry to resolve alone, but whether it's cool or fashionable to, sometimes there's like a dissonance or cognitive dissonance between all of us wanting to have clean energy. At the same time, it's still coming, a big share of it is coming from petroleum products, and yes, that has some effect on climate. So this is something that is larger than petroleum industry itself. We all have to actually educate ourselves and become better citizens and come up with a compromise that will actually do both. So that's something that needs to be there, but energy demand will remain, and for the foreseeable future, a good portion of it will still come from petroleum products. Transitions are never, oh yeah, starting Monday, let's transition right to a different source of energy. That's not how it works. So typical technology takes a minimum of 10 to 15 years to develop.
Thank you. My next question I have is, what ways have you seen companies try to bring more women into the industry? And if we could go to Carrie first, and then Karen, and then Carrie, I would also like to ask you if you could discuss how communications are important within engineering.
Question. Having been on the industry side of things when I was recruiting petroleum engineers to hire, I will say that I think looking at just the industry side of it is a little like looking at the symptom. I think you have to go much earlier in the pipeline to what Tricia and her team does, and others as well, in kind of laying the groundwork in elementary school and junior high and high school to get more women into engineering, specifically petroleum engineering. So, I think we can't put all the onus on industry because, to some extent they work with the pool of applicants, if you will, that are made available to them by the universities. And then the universities are only working with, the applicants they get from high school and such. So it's really a bit of a systemic issue that thankfully is evolving, I think. I don't know the exact numbers. I won't even try to quote them, but I know from my time in school until now, it's a much different looking mix in a good way with, more women involved in petroleum engineering. I know we were just so thrilled to bring Masha on in the petroleum engineering department. I believe you were the first woman on staff, right? And so, changes are coming, and I think it's a long game that Tricia herself has been playing for a long time. Thank you very much for all your efforts. And we don't want to just treat the kind of symptoms of it. We want to go all the way back and kind of how we're educating young girls to high school age and recruiting them into the college system so that then they're in that pool of talent that the industry will recruit.
Yeah, it's almost
Thank you. And Karen, if you could also talk about how you've seen women. Oh, sorry, go ahead.
That's right. It's sorry about the delay again. I'm on the other side of the Atlantic. But it is a bit of a chicken and egg kind of question, because I agree with Carrie, is obviously we need to get people into the pipeline. We have to start early. We have to start, elementary school, junior high. But I think the other thing that a lot of people in my generation didn't necessarily have was strong role models. When I went into a meeting, I was always the only woman in there. I probably had my first female boss, 20 years into my career. And so we really didn't have a lot of people to look up to follow, to sometimes to just ask questions of and vent with. And so I think we've got to work both sides of the equation. We need to get people in, we need to attract and recruit women into the business, but we also need to develop them once they're there. And I think that's one of the key areas that we're focusing on. We've got a very strong mentoring program. We have a women's interest network. We are really trying to train, frankly, the men in leadership positions in particular to understand what they can do to help develop women. Because obviously just saying women, you guys need to develop each other is not going to get us there. And so I think you have to work all along the pipeline. Bring people in, give people opportunities, encourage folks, and give people stretch assignments even if they don't ask for them, because that is something. And there's lots of literature. There's a great book called Women Don't Ask, that sometimes women aren't necessarily as aggressive in asking for the next opportunity and asking to do a really stretch assignment, and that's something we all need to force ourselves to do, but it's also something we as leaders need to really encourage and get people out of their comfort zone, because again, as I said earlier, you can definitely succeed, and we've got to work all the variables to make sure that we continue to develop women.
Thank you. The next question I have is how hands-on are petroleum and geosystems engineering jobs? And can this be more of like a desk job, or are you ever participating in the extraction process? And first I want to ask Heidi from her internship experience, and then we can talk to Karen about her workplace experience.
Thanks for the question, Sammy. For the hands-on part, I don't think it's what you guys are imagining. You're not like the rig hand. You're not like pulling the pipe out of the well or anything. That's somebody else's job. So you can get pretty hands-on in terms of like working with people. But in terms of like them relying on you to like literally like lift stuff, That's if you want to be a rig hand though, I know one of my friends who did that over the summer and he had a very, very enlightening experience. So if you do want to do that, I mean, that's an option and that is more dangerous. But for petroleum engineering, for our internships, it is pretty much as hands-on as you want to an extent. They're not going to let you be a rig hand if you're there to be a petroleum engineer. But so for my experience, I did some internships that were like in offices and then some internships that were in like not the main branch of the company, but like in Midland or in Oklahoma City, where it's not like the headquarters, but it's still an office. And those internships, I was able to go to the sites. So for my production internship, I was able to physically go to the like producing wells and see what was going on. Obviously, I had to have my hard hat, I had to have all my PPE on so that it was safe. But in terms of was I like risking my life for anything, I don't think so. Obviously, you have to be precautious and take all the necessary cautions into consideration. They'll tell you though, so it's not like you're left on your own. But yeah, so that's for my production internship. I got to go on site. And then for my drilling internship, I also got to go on site. And that was really, really cool because I got to, my, sorry, I'm going to backtrack a little bit. My mentor was pretty, not hands off, but like he was pretty free in like what I wanted to do. So if I wanted to go to the rig, like each week pretty much, I could. Since it was in a convenient location and it was pretty close by, I could just drive there. So if you have a mentor or supervisor who is willing to let you go and see things firsthand and experience like the field for yourself, then it can be pretty hands-on. Obviously, if you're in a headquarter location and you're in, say, Houston, where it takes a little bit longer to get to the field, it may be less practical because you may have to drive several hours to get to your field, or in some cases you may have to fly to get to your field. So it's less practical to go see things in person, but yeah, it's pretty hands-on if you want it to be, and I would say it's not dangerous.
Yeah, I do most of my work is in the office now that I'm in a leadership position, but I always make sure I get out to the field. First, you need to understand the environment that you're working in. You know, maybe it's deep water, maybe it's the Arctic, and really understanding what it is the folks that are actually running things, because you know the field guys are the ones who run things. And making sure what it is they're dealing with and what the system is that they're managing and what some of their challenges are. Because if you want to be successful in managing a reservoir or managing an oil field, you've got to work with the people that are actually the field hands, the guys that are out there running things. And then having the partnership, the relationships, and really the understanding of what each other does and how important it is. You can learn a lot from the guys that are out in the field. They know that equipment far better than you do sitting in the office. And so that's really, I think, one of the most important things about going out to the sites is developing the relationships and developing the connection and learning from the guys who are out there running things. Unfortunately, they are still mostly guys, but we're working on that. But that is probably the most important part is kind of developing that connection, because both sides are important. The engineering is important, but the guys that are out there fixing things, running things, they can tell you more about how an engine works than any of your data can.
I have to add one more thing. It might not be obvious, but basically as a petroleum engineering, you're analyzing measurements, and we're talking about a subsurface system. So you don't go and see your reservoir. You see your reservoir through the measurements that are coming to the surface. So essentially, you are behind a computer looking at those measurements. And Zoya already mentioned signal processing. It's all about signal processing to actually interpret those measurements. And then when you actually go to the field, you're actually going and talking to the people who are implementing your directives on the ground, and you have to have good communication skills to develop, to basically be able to execute. But you're not the one going in with a wrench and fixing something, essentially.
Thanks, y'all. Next, if we could hear a little more from Zoya, if you could talk about how will the petroleum industry evolve with clean energy?
Well, the type of experience we have gained in the petroleum industry can help us evolve faster into areas such as geothermal systems, and so to make them more efficient. For instance, the enhanced geothermal systems, we can contribute a lot, and we can expedite the progress in those fields with the experience we have gained recently in the past 10, 15 years in the petroleum industry. In terms of, for instance, production in the areas of production in the areas of reservoir characterization, they can be applied very efficiently to, for instance, the field of geothermal. So as petroleum engineers, it has been mentioned multiple times during this session, as petroleum engineers, we can contribute to many fields. And well, areas such as geothermal is just very easy to apply, and the type of work that we are doing in that area to enhance the
Thank you.
efficiency.
And for Dr. Podanovich, would you like to say anything? Sorry, I didn't know if you raised your hand. Okay. For my final question I have for Carrie is, what efforts are being done in PGE to revamp the curriculum and reflect CCUS as well as geothermal instead of classes such as engineering communications that some find irrelevant?
Too excited to answer. I forgot about the mute.
You did, Carrie.
Okay, I can tell you, having been on the Petroleum Engineering Advisory Board for years and on the College of Engineering Advisory Board, we struggle with this, right? There are only so many hours that we can require for you to graduate with your undergraduate degree, you know, so there's only so many hours. And so how do you fill that up effectively? It is very much a struggle with making sure you get all the technical requirements and preparing you for your career, whatever that might look like. I will tell you that I am biased based on my experience, that people need to communicate, be able to communicate their ideas effectively. The hard truth that I've seen is that your ideas are only as good as your ability to communicate them. You could be the smartest person in the room, but if you're not able to communicate and sell your idea, you're not going to get much traction with it. So the curriculum question is a hard one that doesn't have a simple answer. You know, it's a balance in only a finite number of hours that were, you know, allotted for your curriculum. We can't make you stay there forever, you know, for 5 or 6 years. So I will say, though, that I actually come from a background that biases me to think that it's very important to be able to communicate your ideas effectively. Oh, I'll add.
Masha, did you want to add in on that? Go, Masha.
There's also a little bit of lag, so it's kind of hilarious. So we give you a core curriculum. You find certain subject exciting, go for it. And we also live in the age that there is so many resources and free courses and you name it online, that there is nothing really stopping you from basically going deeper in one of the areas that you actually simply find exciting. All of them are really important, but you also have to kind of take the agency. So if you like communications, they're definitely important, and you feel that you didn't get possibly enough in our major, we give one course, right? So then you need to go and enhance that elsewhere. And there's plenty of, again, You can do structured learning. You can take a course somewhere. You can simply seek opportunities that basically enhance that part. You choose how you learn and how you learn the best. Just make a plan and follow through. And ultimately, you're going to be able to put that on your CV, and that's going to be your core strength. And as we've heard, I think, multiple times, it takes a team. So different parts of the team are good at something. So you get a good base with your undergraduate degree. What people don't understand is that undergraduate degree is just the start. Right? It's like just sort of like a basics. After that, you're in there for lifelong learning because things are constantly evolving and changing. But you haven't, like when I was an undergrad, cell phones just kind of started, okay? We didn't have a cell phone. So now imagine the smartphones and whatnot and all the technologies, and how is the experience of a geologist now when they take an iPad and they just kind of put it on their piece of rock and it takes immediately the measurement that they otherwise needed sort of hand tools to do. So there's the experiences there.
Thank you. Well, thank you all. I'll just throw in one final comment on curriculum. We always encourage students to really check out what are those classes that you take within your major, and they're going to look a little bit different. Petroleum engineering at UT Austin is going to look a little bit different than petroleum engineering at Texas A&M or other universities. So look and see what are those electives you can take, like what Dr. Brodanovic was just talking about. You get to customize a little bit what those pathways are that you take in your undergrad curriculum. But there's also things that are required to have an accredited engineering program, and one of those is engineering communications. Every engineering student across the country has to take something in that space that includes ethics, it includes leadership, it includes things around bias and inclusion, and it includes things about how to communicate, because that's so critical to an engineer's profession. So take a look at that curriculum, decide what works for you, figure out your own pathway, because that's the beauty of engineering. You can take it in any way you want in your undergrad, but also, as you learned from our amazing panelists, you can take it lots of ways when you get out into your career, and that's the beauty of engineering. So I know we're at time. I want to finish up with just a couple of more things to remind you. FabFems Fridays are continuing one more week this summer. We have our fabulous sponsors who are supporting our summer camp who will be joining us next week, Shell Applied Materials and Samsung. So don't miss out on our very last FabFems Friday of the summer. I also want to remind you about the fabfems.org website, our STEM role model database, where you can search for other role models and read about different experiences and stories from engineers all across the globe doing amazing things. You can also find all of our past FabFems Fridays webinars and this one later today, as well as a number of frequently asked questions and all kinds of other resources on our YouTube channel, so check that out. And again, thank you to all of our fabulous and amazing panelists. We really appreciate you taking the time today, and all of you students for joining in and throwing out so many great questions at them. And with that, we will see you next Friday. Thank you, everybody.